Well, I finally made it to chapter 2 in Fire in California's ecosystems, but I only got about one page into chapter 2 today because it was just so jam-packed with information. The main things that it's been talking about is the difference between climate and weather and how that impacts wildfire in California. It's going to be on very different time scales. And then it goes into the three main terms that you need to understand if you want to kind of understand climate in California, and that's jet stream, rain shadow effect, and marine layer. So I'll try to cover all of that throughout the course of this video. First thing is the difference between climate and weather and how that impacts wildfire in California. So one definition that you can use is climate is the average of weather over long time scales. One definition I heard is climate is a 30-year average of weather. So what that might mean is how much rainfall you pick up per year. What are your temperatures like on a yearly time scale? Is it always 55 degrees? Is it always 85 degrees like the equator? Or is it like the North Pole where it's 1 degree in December and then it's 54 degrees during the summer? Or is there not as much variability? That will have big impacts on the kind of vegetation you have, and then that has big impacts on what kind of fire you have. So that's temperature side of things. Also, how much rainfall do you pick up every year? Is it like a desert where you see almost no rainfall? Is it like a rainforest where you pick up large amounts of rainfall? That's going to have impacts on your vegetation, and that has impacts on your fire. Now, one of the most important, and that's going to change over very large time scales. It might be variable year to year, but overall, it's not going to shift very much. And if it does shift, it's going to shift very slowly. So the frequency of fire, when it comes to those variables, over the long time scale, that's going to be fairly stable. Now, one of the big things to know to understand California's climate is we actually have a very large variety of climates. It's very diverse. So we have very diverse landscape. There's a large variety of vegetation. So there's a large variety of fire regimes. It would be overly simplified to say, oh, this is the California climate, because as you know, we have deserts, we have mountains, we have coastline, we have the Central Valley, a lot going on. But when you do think of California, a good thing, if you do need to simplify it, is to think of a Mediterranean climate. So what that means is that you have wet winters and dry summers. And that is actually one of the most important things when it comes to wildfire in California. It's kind of the reason we do have such bad wildfires in California is because at the hottest time of the year, it's also the driest time of the year. That's important because if it's hot, your air will typically be drier. And then if your air is dry, then your fuels are going to be dry. And if you've had a long period of time where your fuels haven't had rainfall, they just get drier and drier. It makes it very easy for a fire to start and then spread rapidly. And then once we get into fall, we start getting some offshore wind events. So you're just checking every box for hot, dry, and windy. So that's not going to change anytime soon. Wet winters, dry summers. So that's what I mean when I say that climate has impacts on wildfire over a very long time scale. Weather has impacts on wildfire over a daily time scale, and in some cases even in an hourly time scale. And the two most important variables, you could maybe debate this, but it'd be relative humidity and winds. So relative humidity is important because the drier the air is, the drier the fuels are going to be, and that is going to change on an hourly time scale. So at nighttime, your temperatures go down, so then your relative humidity goes up. There's a lot more moisture in the air. So fire activity overnight, usually pretty calm. And then during the afternoon, your temperature goes up to 80 degrees, your relative humidity drops down to 13%, and your fire just starts taking off. So that's where weather has an impact on wildfire activity on an hourly or daily time scale. And then the other important variable is wind. Number of reasons wind's important. Actually, you could just think about both of these with a campfire. And I had a bonfire the other night at the beach, and I saw all these factors coming together. So when we started the fire, it was pretty well, first off, we had very dry logs. Much easier to start that fire with the dry logs. That's actually why we were able to get it started, because it was very windy out there. So that had its challenges for starting the fire. But then once it did start, because it was so windy, the fire was going crazy. Some of the photos I have, it looks like our fire is a little bit out of control. But the reason for that, well, there's a number, but one of the reasons is that can actually lead to more evaporation out of your fuels, so it makes your fuels even drier. It also provides more oxygen. Like if you've ever had a fire dying and you blow on it, or you're watching Survivor and they're trying to make a fire and they blow on it, you're providing more oxygen to the flame. And that's one of the things flames need: heat, oxygen, fuel. The other thing that wind can do is it can also just push your flames forward. It can kind of push some of the heat forward, so it preheats some of the fuels ahead of the fire. But kind of the main thing that wind can do to impact your fire on a daily time scale is it can pick up little burning embers, toss them out ahead of the fire, and start new little fires. And this is something we saw in the Dixie Fire. They did great burn operations, so they had this whole protective barrier on the northern side of the fire. The fire was maybe just going to bump into that, there's no more fuel, and then the fire stops in its tracks. But because it was so windy, picked up some burning embers, tossed it over that barrier, and then the fire took off 15 miles in one day. So, climate affects wildfire frequency and intensity over long time scales. Weather is going to affect wildfire frequency over daily time scales, and in some cases hourly time scales. Just to expand a little more on the hourly, we have something within fuels that we call 1 hour fuels, 10-hour fuels, 100-hour fuels. The 1 hour are going to be very small. 100-hour might be about the size of your wrist. And what that means is that's how long it takes for the fuel to respond to the moisture in the air. So your very fine fuels, in 1 hour, the dry air is already making that fuel drier. So again, that really just drives home the point of weather variables impact your fire today. So I think that pretty much sums up that part of this chapter that I was reading, or the one page that I was reading. The next thing it goes into is the 3 important climate terms. Well, there's a lot of climate terms that you want to understand for California, but 3 big ones and 3 good ones to start off with are jet stream, rain shadow effect, and marine layer. So we'll go with, I think, maybe the more difficult one first, which is the jet stream. So jet stream, you can think of this as westerly winds, and the most important thing to understand is during winter, the jet stream drops down into California. And what that does is it brings some of the storms from Alaska down into California. That's why we pick up a lot of our rainfall. And then the jet stream is going to be stronger during winter. And then during summer, the jet stream is going to shift back up north. And then we're not going to have rainfall in California. That's a big part of the reason we have a Mediterranean climate. So I said something there that you might question. I said the jet stream is strongest during winter. So the reason for this is because our temperature gradient from the equator to the poles is strongest during winter. And I know temperature gradient's kind of those big words. What does that even mean? And to be honest, I didn't totally understand what it was saying right there until I looked at some figures in the textbook, and I was like, oh, I got this now. So I'll try to explain it. So temperature gradient, that just means difference in temperature between the equator and the pole. And it's a larger gradient during winter than it is during summer. If that doesn't make sense, let's just throw out some numbers. Let's say the equator is just 80 degrees all year round. And that's a pretty good estimation. Your weather doesn't change or your temperatures don't change very much throughout the year on the equator. Whereas on the pole, it might be 0 degrees during December, and then it might be, let's say, 50 degrees during September. Now look at the difference. During December, you have an 80 degree difference between the equator and the pole. And then during summer, you have a 30 degree difference. Now, the best way I can explain this is using a metaphor. Think of if you have a tray, and you tilt that tray a little bit. So this is thinking about summer. And you pour some water on that tray. The water is going to flow down, but it's not going to be flowing very quickly. Now let's tilt that tray way up. This would be winter. And then pour some water on that. That water is going to flow very quickly. This is the same thing that our winds are doing in the atmosphere. When it's 80 degrees to 50 degrees, winds not as strong. When it's 80 degrees to 0 degrees, winds and the temperature gradient or the temperature difference is much larger. The jet stream is just where those two boundaries come together and where your tray is the steepest. So where your warm air is bumping into your cold air, you have a big difference. Your tray is very steep, so you have your windy conditions. That's where your jet stream is. During the winter, that shifts south, and then that brings the storms with it, which is why we pick up our rainfall during winter. Hopefully that made sense, and also hopefully the garbage truck outside isn't too loud and then my microphone's not picking it up too much and it's not too distracting. Let's go into the second term that I mentioned, rain shadow. So I mentioned that California picks up a lot of its rain during winter, but it's not uniform throughout the state. And one of the big differences in how much rainfall you're going to get is what side of a mountain range you're on. So because it's the westerly winds from the jet stream that bring in our rainfall, that air is going to be flowing from the west, and then it's going to bump into the mountains in California that mostly span from north to south. As it bumps into, I should maybe do this backwards, I think the camera switches it. Your westerly winds come in, as it bumps into the mountains, that air is pushed up. As it rises up, it's going to cool down, and cold air can't hold as much water vapor as warm air can. So some of that water vapor is going to be condensed into clouds, and then almost like squeezing a sponge on the westward or windward side of those mountains, you're going to get a lot of rainfall. That cloud's going to be squeezed out, you have a lot of rain, that's going to impact your vegetation, that's going to impact your wildfires that you have on that side of the mountain. Then on the eastern side of the mountain, that air is going to be going down, it's going to be heating up as it goes down, but a lot of the moisture's already been squeezed out of it. So that's where you often see deserts, or on the eastern side of the mountain. So just in a short period of time, you have very different vegetation, or short period of time, I guess if you're traveling, but a very small distance. You have very large differences in vegetation, which is going to lead to large differences in your fire regime. I think that pretty much sums up that one. Now, the last important vocab word to know is the marine layer. So usually during summer, we have warm air moving in over California, and that air is going to be a lot warmer than the ocean. Now, the exception there is this thin layer of air just above the ocean that is moist and cold, and that's what you'd call the marine layer. Now, the main thing to understand in terms of a wildfire context is when you have moist, cold air right by the surface, and that sometimes pushes over our coastal communities, sometimes it pushes all the way into the Central Valley, but you're going to have cold air below warm air. Now, warm air likes to rise, and it's less dense than cold air, so if you have warm air below cold air, you have less dense air over more dense air, and that warm air is going to want to rise up. So it makes a very unstable atmosphere. Things are mixing around that can lead to thunderstorm development, rainfall. Whereas when you have this marine layer, cold air, below warm air that's moving in, that's a very stable atmosphere. And the reason that's important in a wildfire context is a stable atmosphere produces less rainfall and can lead to prolonged drought. Prolonged drought leads to drier fuels, leads to more wildfire. So that's three of the most important terms. It's also the difference between weather and climate in California. I'm one page into chapter 2. I will slowly work my way through this entire textbook. If you want to learn more about wildfire, especially in California, you can come on this journey with me, and thanks for watching.